Hi, good afternoon. So this is review material. So for the students that want to take an extra solving quiz and an extra solving test, this is the test that you took March 13th, did the day that we last attended school and we went into quarantine. So this is now the third test that we've taken this semester. So I'm going to review solving by quadratic formula, solving by square roots, that'll be another video, and then solving by completing the square, and that will be a third video with assignment. And then I'll offer a quiz, and then I'll offer a test. Okay, so just like what you did with the extra factoring quiz, extra factoring test. Okay, I'm still gonna move ahead with the graphing by intercepts. I think I only need the graphing quadratics by solving by completing the square. I think that's the only one I have left. Okay, all right, here we go. Okay, this is one video. It will be solving quadratics by the quadratic formula. It's review material, so this is a lecture and the assignment. So after I will do question number 1 and question number 5, but I'm going to first let it just kind of pan over the sheet so that you can copy it, and I will do 1 and 5. Okay, so quadratic formula, x is equal to big long fraction bar. Okay, your numerator is minus b plus or minus big square root. B squared minus 4ac is all under this radical. And then your denominator is 2a. Remember, all of these problems will already be set up in standard form. I'm not going to give you the tricky ones or the ones that are not in standard form. I could maybe do that like the last week or just the special cases. Y is equal to ax squared plus bx plus c. Remember, your a coefficient is a coefficient of x squared, your b value is a coefficient to x, and your c is your constant. And all we're doing is we're allowing y to equal 0, and that's why we're able to write 0, 0, 0, 0, 0, 0. I think there's one more, 0. And so by letting y equal 0, that is why we are able to solve for the roots 0, x-intercepts. Remember, in order to find the x-intercept, you let y equal 0. Okay, so we're going to solve just 1 and 5 because this is imaginary. This will be a nice, clean, real number. Fair enough? Okay, so here we go. Let me solve 1. And I think 1, 2, 3, and 4 will be real. And I think 5, 6, and 7 will have the imaginary unless I made a mistake somewhere. So when we get to 5, I'll come back to here. Okay. All right. So let me just pan over it. And you could either pause the video, copy. Fair enough. Here we go. Okay, so for question 1, we need to label our ABC. So A, B, C, correct? So A is equal to positive 2, B is equal to negative 11, C is equal to positive 15. Okay, now if you would like to solve it by hand, you may. This is my fraction bar. All right, so I'm just going to go ahead and substitute. Remember, it's minus b plus or minus big square root b squared minus 4 times a times c, make it a little longer, all over 2a. So I'm just going to go ahead and substitute that, right? That's it. Okay, it is the b value, right? The b value is negative 11, so I'm put a negative 11 here. This is b squared, so b first, negative 11, right? Minus 4, ac, my a value is 2, my c value is 15. That was just an accidental marking by my pen. 2 times a, so a is 2. Okay, there you go. Now, again, if you have the calculator, we're just going to straight put it in the calculator. So hit the fraction bar, and then here's my negative, parenthesis, negative 11. And if you want to kind of perform some mental math and put a positive 11 here because you understand that these signs are getting switched, then that's fine. Okay, so let's take the positive first. Positive, square root, and remember as we type, it grows, negative 11. Squared minus 4, a is, I think I said 2, 15. right? Minus 4 AC. So what you see is what you type. And then 2, 2. Right? Okay, I'm going to hit equal. Hopefully I did this right. Hit equal. Let's pan out. And I get 3, right? Okay, so one of my solutions is 3, right? Remember, solve for the roots, zeros, x-intercepts. Okay, so there's our 3. So now I'm going to click back. Go up and back. Up to hit the numerator. Okay, I'm going to delete this positive. So I'm going to hit that delete button. Let's see if I have the pen. Hey, it worked. Okay, and then subtract, and now hit equal. 5 halves, take it to SD, 2.5. And so there you go. That's it. Those are your answers. Fair enough? Okay, so let me just solve this by hand really quick. Negative, negative is positive 11, plus or minus, square root. That's 121. Minus 4 AC. Let me think. This is 30. 30 times 4 is negative 120. 2 times 2 is 4. X is equal to 11, plus or minus. 121 minus 120 is 1 all over 4. Again, what is the square root of 1? 1, right? So 11 plus or minus 1 all over 4. And remember, your division of 4 is the last step. If you are dividing the 4, if you had done it prior, your answer's trash. You need to do it at the very, very, very last step. Okay, 11 plus 1 over 4 and 11 minus 1 over 4. So this gives me 12 over 4, which is 3. Yay, there's my answer. Oh, sorry, there's my answer. And then 11 minus 1 is 10 fourths, which is 5 halves, which is 2.5. Yay, and there's my answer. Okay, I totally bled into this, but guess what? I'm not doing 2 and 3 and 4. You are, so I just have to go down to 5. Go to 5? Let's go to 5. Okay, what's our A value? A is 8. B is positive 6. C is 2. Okay, remember, we're dealing with imaginary numbers here. So 5, 6, and 7. Okay, we're going to get the I. Remember, when you get a negative radicand, we're going to get kicked out of this. It's going to give us math error. So I'm going to purposely put this into the calculator so we can get rejected. Okay, so then we have to solve this by hand. Remember, you are going to get a complex number root. Remember, we're solving for roots, zeros, x-intercepts. We're going to have a complex number, which means there's a real number component and there's an imaginary number component. These two cannot add together, okay? Okay, so here we are. Remember, this is our review. Okay, x is equal to minus b plus or minus big square root b squared minus 4ac big fraction bar. I'm not even writing pretty. My hand's all in the way. 2a8. Okay, I'll pull it away and let you guys look. Okay, so minus b plus or minus b squared minus 4ac 2a. Perfect. So I substituted correctly. Okay, if I so badly want to get rejected, so let's throw this in the calculator. Okay, minus parentheses 6 plus square root 6 squared minus 4, 8, 2. All over 2a. Okay, here we go. Math error rejected. Okay, that tells you that you did everything correct. You substituted correctly. I put it in the calculator correctly, but you are getting a negative radicand, and so that is an imaginary. This calculator does not process that, so we can use it to maybe do some basic arithmetic for us, but it's not going to give us our answer. So we got to do it by hand. Okay. Minus 6 plus or minus 6 squared is 36. Minus 4ac. Okay, so this is 32. 32 times 2 is 64. So minus 64 all over 2, 8, which is 16. So minus 6 plus or minus, what's 36 minus 64? I have no idea. 36 minus 64, negative 28. This is like where I would mess up. minus 28 all over 16. Okay, so there is our negative, right? It's right here. Okay, so if you have your negative, you better present an imaginary I. Okay, so then this is going to become x is equal to negative 6 plus or minus, okay, 28 is 4 times 7. 4 is a perfect square, right? What's the square root of 4? 2. So 2I rad 7 all over 16. Okay, this is a good enough answer. So if you do not have access to a calculator to get a decimal, right, but you should understand your perfect squares, 28 is 4 times 7. 4 is a perfect square. The square root of 4 is 2, right? Just like 4 is made from a pair of 2's. 7 is a prime number. You can't break it down. Okay, this is good enough. If you wanted to reduce, right, see how it's 6, 2, 16. See how each of these is divisible by 2, right? This would be 2 times 3. This is 2 times 1. This is 2 times 8. I could reduce by 2, and I would get plus or minus I rad 7 over 16. This is also in perfectly reduced form. This one is absolutely gorgeous. Gorgeous. This is beautiful. Okay, however, could you just take it straight to a decimal? So if you're here and you're like, come on, Miss Kinney, I'm not going to do all of that. I want a perfect complex number. What do I do? Okay, so break this up. So it's negative 6 over 16 plus or minus negative rad 28 or rad negative 28 all over 16. So throw that in your calculator. And so what is negative 6 down 16, right? Because that's what I have, negative 6, 16. And I get, what do I get? Negative 3/8, which is negative 0.4. We'll just go that way. Okay, negative 0.4. So this is my real number component, right? So that's my A. This would be my A. And now I got to get the BI. Okay, so it's going to be plus or minus, and then I have to put the BI, right? Because that's a complex number. Okay, I already know this has an I. That's because of the negative. So let's just, whatever, we dealt with that. Okay, so let's now take the square root of 28 over 16. So 28 down 16, and I get 0.3. And so, I don't know if I'm going to be able to squeeze it. And so that is your answer as a complex number. That's it. Now, here, if you're asking, well, okay, I went from here to here, but are these equivalent? Yes, these are all equivalent answers. So if I took, well, that one's already split up. So if I take this one, okay, negative 3 over 16, negative 3 down 16, I get, what am I looking at? Oh, you guys, I didn't divide by 2 here. This is 8. I'm so glad I checked. I was like, that's not coming out right. You guys, I divided by 2. Divide by 2, 3. Divide by 2, 1. Divide by 2, 8. Hello, that's terrible. That should be an 8. Okay, good. I'm glad I checked it. So for those of you watching the video and you were like hollering at me through the video, my apologies. Okay, so negative 3/8. So now let's go back. Negative 3 down 8. And there is my negative 0.4. Okay, so now take rad 7 down 8. Oh, you can't even see, I'm sorry. And you get 0.3i. So it's equivalent. Okay, so before, yeah, I just don't do that, you know, human mistakes. Okay, so this is still wonderful because you're able to do the arithmetic to the quadratic formula. However, you have to show that you understand imaginary. And so with that negative radicand, you got to pull it out and make it an I imaginary. Now, you can go straight to the calculator, substitute numerator divided by denominator, and you will get the same answer. So whether you take it by reduced radical, and then, of course, you reduce your fraction, right? Your numerators, your denominators, your rational expression. Or you get this. That's an 8, by the way. This looks horrible. Or you can get the complex number here. Okay. All right. 6 and 7 will be this way. There's your assignment. Okay, goodbye.